I've now popped jQuery in because I like jQuery, and I know that makes me retrograde, but whatever. Yeah, I know. All right. And then inside of a script that I've included here, I basically just have a simple flip-flop. This works by touching on the screen, because what I've done is inside the scene, what I've said is I've added an on-click. So if you know JavaScript, that means that if there's a click in there, it's going to call that function. So this is the thing. They really do act like real tags, because I can attach events to them. And so what happens is when that happens, every time there's a click, I flip between two different texture maps, one of which is the Martian surface and one of which is the Earth surface. And so if you actually load example 9, you see down here, this is where the I've added a new asset on there. And I leave that as a problem to solve for you. You want to seriously, it'd be easier to resize Mars, just change the radius value, right? So you could totally do that. So we do that, you take a look. All right. Yeah. Where is that? Where'd it go? Oh, there it is. There. It's okay, so that's all working. All right. So the idea here is that there's complete equivalence between what we would think of as normal DOM manipulation with all of this stuff and all of the stuff that's going on inside of the model. Now, the great thing about this is that if you ever get lost or confused by what you're doing, on the desktop you hit Control-Alt-I. There is a full inspector built into A-frame. Exactly. Now, let me show you what that means in practice. Okay. So, as a final example for you guys, if you go to the last example, which is the clock example, and load that up, that's at the bottom of the page. And there's a bit more code there, so I'm not going to go into the code itself. But what that is this is actually a clock that's fully immersive. So that is the correct time. And you can look around, you can see the second hand going around, it's over there. There's the hour hand, and there's the minute hand, and all of that. And that's all happening through JavaScript. But if you actually wanted to inspect what was going on with it, you'd hit Control-Alt-I. And there's the scene right there, and you can see this little second hand going around and the whole thing. And you can click on things, and when you click on them, you see you get an inspector. I could change the values. If I change the values to things that I like, I could then hit the Save as HTML button, and it would save the file with my changes. So I have a tool not just to figure out what's going on, but I can move things around, and when I have them where I want them, I can then save them.
Can you also right-click inspect?
I haven't tried. Let's have a look.
So is this interface
No.
part of the A-frame?
It's built in.
Yeah, right.
Okay, so A-frame is cool because A-frame, when you grab when you just include A-frame, you're getting 3JS, you're getting A-frame, you're getting the WebVR polyfill, which is why it's working on all of the phones in this room that don't have WebVR on it, and you're getting the inspector. Mozilla is trying to make this as easy as possible for people who have never done 3D before to actually start making cool stuff for the web. All right, and I wrote this. The clock took me about an hour this morning, and most of that was, there's one downer. You're going to have to either remember or relearn some trigonometry. Because trigonometry is simply how things work in 3 dimensions. And so if you can remember how sine and cosine work, or you can Google it, then you'll be all right. Because I had to do that in order to be able to move the second hands around. But the code for that.
You sure there's an app?
Huh?
There's an app for that?
There is. I'm sure there's an app or two for that. All right. And that's a screenshot of how the clock looked. I actually turned the background down on that, which I probably shouldn't have, because that's actually a little bit easier to see. questions? Yes.
So if you're creating these web VR experiences, I guess it depends on how good the internet connection is of the person using the experience, right?
Yes. But these are all
So they've
very
got a
small
really-
files.
Okay, right. So they got a really bad Vodafone prepaid account. They're
Right.
not getting much internet through there. Is that going to lag and make people sick because it's not coming through?
No, okay, so that's a good question. The answer is no, because the rendering is all happening on the device, whether it's the phone or whatever it is. It's not what's happening in terms of downloading assets. So you can decide whether you're going to show assets or not. Assets will blink in, all right? A-Frame kind of wants to have all of the assets downloaded before it will render. You can tune that, but that's A-Frame's natural set of defaults. So for that reason, you would never get a bad experience. It's just that someone who has low bandwidth would wait longer until you get the full scene loaded. Okay?
Are we going back to a low poly kind of
No.
experience?
Well, okay.
We've been judicious.
The answer to that, I mean, if you were judging by how it works on the Gear VR, I would say there are no polys. That doesn't make that thing go low. All right. WebGL is incredibly performant. So I don't know if you know, there's one called the WebGL Cubes demo. All right. It's 1.5 million polygons. And on an iPhone 6s Plus, which is what I have, 40 frames a second. Okay? On the Galaxy S7, 7 frames a second, because they have a crap WebGL implementation. All right? On the Pixel, 45 frames a second. So a lot of it's going to depend on where that is in that. One of the nice things about these frameworks is these frameworks actually do allow you to detect what frame rate you're running at. I don't know if A-Frame's got that specifically in it. 3GS definitely does. And so you can figure out, I'm running like crap on this person's phone, let me drop back to something like that. So that's something you may want to think about as
I wasn't thinking so much about the rendering rate in
Right.
front. I was thinking more about the connections being pulling geometry.
Well, I mean, if you take a look, the interesting thing around this is if you're using the sort of the pre-builts that are in A-Frame, those will pop in super fast because they're just tags and you're just parsing that. If you're bringing in a model, which is very detailed and textured, yes, there's going to be some time associated with that. So people have done a lot of real estate work and things like this, and so you have to think very carefully, because real estate has a very simple geometry but quite rich textures, right? So you think then about optimizing the textures so that you're getting the most bang for the least amount of transport, right? Just as if you were loading a web page. Yes?
In terms of texture resolution, how high can you go with this? How many texture maps can you bring in?
I think it's going to vary a little bit based on the devices. What you're going to see is that WebGL likes to have texture maps that are powers of 2 in each dimension, and if it doesn't, it tends to downsample it to something that's quite crappy. So the example that I showed you of all of us in here, that was probably downsampled because I didn't take time to Photoshop it and make it to a power of 2. But generally what it will do is it will sit and downsample in the background for you. So you want to be sort of sensitive to what the renderer is going to do, and it's just one of these other things that we have to worry about right now. But in terms of that, most modern, so current generation mobile phones have enough RAM and GPU in them that they can handle a fair number of texture maps. But I guess we're going to find out when you hit a limit or when something starts to stutter because you're paging out because you've got so much texture in there. Generally, it's not going to be a big problem because you have GPUs that have either dedicated RAM or a large pool of RAM that they're sharing, which means that it'll be fairly rich textures. But it's hard to know that yet.
And besides texture maps, normal maps, displacement maps, those work?
They will work in 3JS, which means that you could write your own A-frame nodes to implement all of that, because that's all in 3JS. Whether there are pre-built A-frame nodes that give that to you right now, go take a look at what other people have contributed, because what the Mozilla folks are doing is quite sort of standard, basic stuff, simple stuff. But I think what the contributors have added is probably a lot of stuff around that, because it's really easy to be able to go, okay, I want to have the shape and I want to have the bitmap for it, and here's how I want to bring it in and apply it to that
But
geometry.
WebGL is capable, right?
Oh yeah. Oh God, yes. WebGL is GL. So anything that GL can do, WebGL more or less can do. So yeah.
And where do you think A-frame is going? Is it going to be standardized or it remains as a popular framework? And is it going to add more features like in Unity or Unreal Engine to keep adding those?
Yeah, I mean it's only A-frame's only 6 or 8 months old now. It's moving very, very rapidly, and it's only recently like. I wanted to sort of start teaching this a little bit earlier. This is, by the way, and forgive me, this is the first time I've taught this, but this is the first time I'm taking it out. Thank you all for being good listeners. Because it wasn't ready for me to actually teach it yet because it was just too buggy, but it's now at this point where it's not only not buggy, but it's actually quite stable and it's working across enough browsers. Because this would all have worked fine in Chrome as well if I wanted to do the examples in Chrome.
Yeah.
So the answer is it's growing very rapidly. If you go and take a look, they do a weekly blog.
Yeah.
Go take a look at the weekly blog, because the weekly blog shows you how many people are using it and how many features are being added and who's adding them. And it's not just the core developers who are doing it. So it's, in terms of WebVR, it is the most active project in WebVR right now. Yes.
Why A-frame and not X3D? See, nothing in the demo couldn't have been done 10 years ago, 20 years ago in VR.
Or in Glam. All right, which and you know, Tony blew off a little steam at me. It's like, yeah, the A-frame folks, they took Glam and they. I don't think that there's anything that's specifically different about it other than JavaScript is 2 orders of magnitude faster than it was with X3D. All right, and the renderers are 2 orders of magnitude faster than they were with X3D. Okay, so I don't think there's anything that's, say, particularly good or bad. That said, X3D was fixed. If you wanted to add new features, you had to do protos and all of that, whereas this is completely open. Oh, and that's right, I do have one last thing I want to show you guys, which is the largest scale project that's been built in A-frame. So A-frame is not just for toys. The guys behind A-frame built a tilt brush clone called A-Painter in A-frame. This is up, you can go and use it. If you have a Vive, you can go and play with it. But because it was built in A-frame, you can add your own brushes to it. So it is not just completely extensible, they are inviting you to add your own brushes to it. What I want to see happen is I want to see people adding not just painting brushes, but data brushes. So you'll be able to come in and sweep a data brush over something and actually have something change its visualization, not just change its content. All right, yes? Well, last question.
Sorry, just a quick one. So if you got the Daydream headset, you've got the control pad that goes with it.
Yeah.
Is that able to recognize that through A-frame?
Okay, so this is a really good question. Thank you for asking this. This is actually a WebVR question rather than an A-frame question. So WebVR doesn't care about the controllers. What does care about the controllers is the Gamepad API. So you have to make sure that the Gamepad API is enabled in whatever browser you're using. And then it's up to whatever app is talking to the Gamepad API to get events in. All right? Now the Gamepad API is designed to be able to handle X, Y, and Z, or pitch, yaw, and roll on the Google device. So the answer is it should be there from day one. The question is whether who's ever written a particular app has handled that specific device, because there isn't abstraction in that sense yet between all the different kinds of controllers that we have in VR, because it's just exploding too much right now. I mean, this was, I guess, yeah, he's gone, isn't he? So I know this was one of the themes at the WebVR Meetup, but there's just too much going on right now to know. So everyone says, okay, we're using the Gamepad API. And so you'll be able to get all of the normal events in from the Gamepad API. And the nice thing is with the Gamepad API, you can have many kinds of controllers. You can have a Gamepad controller in addition to having Vive controllers, and they'll all work simultaneously. Okay.
And do you think A-frame or similar framework will replace or kill game engine-based VR in the future?
No.
No.
No, it's an ecology. No, because game engines are highly performant. right? The web is high performance, but it's high performance around an extremely densely informational connected environment, right? And so what you get is you get access to everything. What you sacrifice is that there's probably some performance trade-offs, right? Whereas when you're in a game, you're in your own tight little universe, and it's meant to be that thing. So if you're talking about things that are metaversal, you'd do the metaverse on the web. You wouldn't do the metaverse inside of an app because it's not enough metaverse. So I think it's going to be that kind of trade-off, just the same way that you see apps on phones being highly performant because they're dedicated to something versus web apps, which are available and tied into a lot of data sources.
Okay. There'll always be a trade-off between these.
I think so. I mean, that said, WebASM was released 2 days ago, right? So WebAssembly, when it meets WebGL and WebVR, is going to make the browser almost as performant as a dedicated app. That's probably still about a year out. So I guess we'll see at that point.
Wrap up?
Yeah.
Good, thanks.
Thank you.
Yeah.